Hello my dear students, how are you? Namaste to all. Today I am giving a very interesting lecture about the nascent hydrogen and molecular hydrogen. It's very useful for knowledge as well as examination view of point. Yes, and generally asking exam is very important. So first one is nascent and molecular hydrogen. Yes, so at first we have to know what is nascent. Nascent hydrogen means newly born. In short, we can say newly born hydrogen. It is produced by the reaction of granulated means pieces, granulated zinc and dilute sulfuric acid. It is very reactive in nature. It is strong reducing agent. Its lifespan, lifespan is fraction of second. You can say negligible. So its lifespan is fraction of second. So that is about what is nascent hydrogen. Next one is molecular hydrogen. It is stable, having free existence and it is stable, having free existence and we can say so having free existence and properties of any compound determined by molecule, not by atom or nascent hydrogen. Yes. So that is about what is nascent hydrogen. That is newly born hydrogen. It is produced by the reaction of granulated zinc and dilute sulfuric acid. Is very reactive in nature. It is a strong reducing agent. Its lifespan is fraction of second. So molecular hydrogen talk about the molecular hydrogen. It is stable, having free existence and properties of any compound is determined by molecule, not by atom or nascent hydrogens. You have clear what are the main differences between nascent hydrogen and what you see molecular hydrogen. So generally question is asked in examination sometimes in 5 marks or sometimes what you see 2 marks. Yes. So what you say? So sometimes how can you question this? Question is like this. How can you show nascent hydrogen is more powerful reducing agent than molecular hydrogen. So sometimes ask you 5 marks, sometimes ask you in 2 marks. So if asked in 5 marks, then we have to give 3 experiments. If 2 marks, then you can give 1 experiment. Yes. So like this, like this. So first one is what is a reaction with acidified solution of potassium permanganate Yes. So that experiment is generally asked in examination. So reaction with acidified solution of potassium permanganate. So we see experiment like this. So for this we take test tube. Test tube always what we see clean. Yes. So in this test tube we take 2 ml milliliter of acidified solution of KMNO4 potassium permanganate. Its color is what you see pink. Yes. So in this solution with the help of delivery tube, that is delivery tube. So what we pass? The hydrogen gas which is what is prepared in the lab, that is delivery tube. That is what you see test tube. Yes. So at first what you take 2 ml of acidified solution of KMR. What do you mean by acidified? So in this solution what we have to add? Dilute sulfuric acid. Yes. Then with the help of this delivery tube, what we have to pass over here? The hydrogen gas which is prepared in the lab. So what we see, what we observe over here, when you pass 1 second, 1 minute, 1 hour, whole day. So what we observe over here, there is no any reaction over here. So in this case, so what you see in this case, there is no any reaction. Question arises, why? Because the hydrogen which you pass through the solution already converted into molecule, and if there is formation of molecule, it does not participate in the reaction. Yes, it's very stable. Yes, so it does not participate in the reaction. Suppose this is the experiment number 1. Yes. So what we see over here? So when that zinc is treated with dilute sulfuric acid, so what you get? Zinc sulfate plus what you see? Hydrogen gas. Yes. And that hydrogen gas when passed through what you see? KMNO4 potassium permanganate which is acidified with dilute sulfuric acid. So, first experiment, what we see? No reaction. Why? Question is why? Because the hydrogen which you pass through the solution already converted into the molecule, and molecule itself does not participate in chemical reaction. That is the first experiment. Now, second experiment, we take another test tube. What we take? 1 2 ml of acidified solution of KMnO4. Color is what you see? Pink. So, in this case we are not passing what you see hydrogen gas over here. So, in this case what we take? 2 pieces you can say 2 pieces of granulated zinc. Granulated means like grains. Zinc is added in this test tube. So, what we see, this is experiment number, suppose this is experiment number 2nd. So, in this case reaction what we show? Reaction is very fast. Question as why? Due to formation of nascent hydrogen, and what you see, pink color is changed into colorless. Yes, so I will show you why. So, first experiment what we see, when I take acidified solution of KMnO4 and when with the help of this delivery tube pass the hydrogen gas, what we see over here? There is no reaction. Question arises why? Due to formation of molecular hydrogen, so because it does not participate in chemical reaction. In second experiment, what we see over here? When we take 1 2 ml of acidified solution of KMnO4, its color is pink. When 2 pieces of granulated zinc is added in this solution, so what we see, reaction is very fast. Now, question arises why? So, reaction is very fast due to formation of nascent hydrogen. You have clear? And in this case, what we observe, pink color is changed to the colorless. Now, question arises to what type of reaction it is. So, in experiment number 2, what the reaction over here? Zinc plus dilute sulfuric acid. So, what we have? Zinc sulfate plus nascent hydrogen, that is nascent hydrogen. Yes. Now, this nascent hydrogen is reacted with acidified potassium permanganated means sulfuric acid. So, what you see, reaction is very fast. So, what you see, redox process is reduction. So, what you see, +7 oxidation number. In this case, what the color of this one? Yes. So, in this case KMnO4, the color of this one is potassium pink, that is potassium permanganate. Yes. So, what we see, K2SO4, MnSO4, yes, plus S2. Yes. So, what we see in this case, Mn plus 2 oxidation number. So, its color is colorless. So, what do you see? So, in this case nascent hydrogen reduces pink color of potassium permanganate into colorless manganese sulfates. So, what this reaction shows? Ki what you see, nascent hydrogen is more powerful than reducing agent than what you see, molecular hydrogen. Yes. So, balance is like this. So, suppose balancing is 2K-4 when you balance this one. So, what you see, 2H over here like this, 2K-4, 3H2SO4, 3 dilute sulfuric acid, K2SO4, 2MnSO4 plus what's 8H2O. What to get? 8H2O. Better to write 8H2O. Yes, we have clear. So, how can you show nascent hydrogen is more powerful than what you see, molecular hydrogen? So, I am writing you in language. So, you have clear. So, write down the language. When hydrogen gas is passed through acidified solution of KMnO4, there is no any reaction. Experiment number 1. Why? Reason is due to formation of molecular hydrogen. Yes, we have clear. In first experiment there is no reaction. Yes, but in second yes, but when two pieces of granulated zinc are added in acidified solution of potassium permanganate, there is fast reaction. Fast reaction. Why? Reason is due to formation of nascent hydrogen, which reduces pink color of potassium permanganate into colorless manganese sulfate. This experiment shows nascent hydrogen is more powerful reducing agent, then molecular. So we have already seen in first experiment. So when you pass the hydrogen gas directly in acidified solution of KM4, what there is no reaction. Why? Due to formation of molecular hydrogen. But when 1-2 pieces of granulated zinc are added in acidified solution of KMnO4, so what we see over here, reaction is very fast. Why? Due to formation of nascent hydrogen, and it reduces pink color of potassium permanganate into colorless manganese sulfate. The name of this compound is manganese sulfate. See, this oxidation is +7 Mn, but in this case Mn has +2 oxidation number. So it is clear from experiment as well as what to see reaction. So you have clear. So I have already given you the language. So if you ask in examination, you can write like this. Now second, the reaction with acidified solution of potassium dichromate. Yes. So language is same. So when you write, when hydrogen gas is passed through acidified solution of potassium dichromate, there is no reaction. Experiment 1. Due to formation of molecular hydrogen, but 1-2 pieces when 1-2 pieces of granulated zinc are added in acidified solution of potassium dichromate, there is fast reaction, due to formation of nascent hydrogen, which reduces potassium dichromate with potassium dichromate into green colored chromium sulfate. So this experiment also shows that nascent hydrogen is more powerful than what we see nascent hydrogen. Okay, what is the molecular hydrogen? So reaction is like this. Suppose experiment number 1. So what you see, zinc plus dilute sulfuric acid. So what you get? Zinc sulfate plus hydrogen gas. Yes, when this hydrogen gas is passed through potassium dichromate, which is acidified with dilute sulfuric acid, that is potassium dichromate. Oxidation number of chromium is +6. So in this case, what you see, process is reduction. Yes, so what we have? Potassium sulfate, chromium sulfate, H2. So color is, that is chromium sulfate. So its color is, what you see? Chromium green color. Yes. So in this case also +6 to +3. Sorry, H2, there is no reaction. Oh, sorry. In this case, no reaction. No reaction. Why? Due to formation of molecular hydrogen. In second experiment, what we see? Experiment number 2. So what we see in this case? So experiment number 2, reaction is zinc plus granulated zinc plus dilute sulfuric acid. So what you get? Zinc sulfate plus, that is nascent hydrogen. Yes. So 2 over here. So when this nascent hydrogen, when react with potassium dichromate, dilute sulfuric acid, process is reduction, and what to get? K2SO4 plus chromium sulfate plus H2O. 3 valency, that is green. Chromium sulfate, that is potassium, that means color is orange yellow color. Yes, you have clear कि what you see, molecular hydrogen. So molecular hydrogen does not participate in reaction, but what you see, nascent hydrogen participate, and we get the reaction very fast. Yes. Now the third experiment. Third, reaction with acidified ferric chloride solution. Yes. So language like this. When hydrogen gas is passed through acidified solution of ferric chloride, there is no reaction. Why? due to formation of molecular hydrogen. That is the experiment number 1. Yes. So reaction is like this. But when two pieces of granulated zinc are added in acidified solution of ferric chloride, reaction is very fast. Why? Due to formation of nascent, which reduces reddish brown colored ferric chloride into pale yellow, or we can say light green ferrous chloride. Yes. So reaction is like this. Experiment number 1. So what to see? Zinc. So in case ferric chloride, so better to take dilute HCl. Same function, dilute HCl. So what we have? Zinc chloride plus hydrogen gas. So 2Cl. So what we have to do? So now this hydrogen gas and pass to ferric chloride solution. So what's the acid? So in this case, what is the no reaction? Yes, I have already given you language. Yes. Yes. Now experiment number 2. So what to see? Zinc plus dilute HCl. What to get? Zinc chloride plus nascent hydrogen. That is nascent hydrogen. Yes. So when this nascent hydrogen treated with color is reddish brown colored solution, not PPT. So what to get in presence of dilute HCl? What to get? Ferrous chloride plus HCl. So what to see? Plus 3 chlorine, so plus 3 oxidation of 2. So what we have? So that is light green. So we have clear. So nascent, how can you show nascent hydrogen is more powerful than molecular hydrogen? If asked in 5 marks, then we have to give all the 3 experiments. But 2 marks you can give any one reaction out of 3. Yes. So thank you for watching this what's important video I think you have also subscribed it and convey to your friends for learning. Yes. So have a nice day. What is it? Healthy, be happy, be healthy. So always keep in mind, always keep a smiling in your face and do out the liver. Yes.